logistical things. It often happens that there's logistics that we have to start with before we can actually get to the physics. It is what it is, and I want to make sure that you are aware of everything that's coming up. I had been living in a nice haze of it's October, saying, oh, no, this trimester is not coming to an end, and holy bananas, it really is. It is, for better or worse, whatever way you want to look at it, it is coming to an end, and 2 weeks from today, you do not have school because the trimester will be over. Does that make sense? Like, it's fast. So I just want you to be kind of aware of where we're at. I'm going to give you just a little look at what our schedule looks like between now and then. Please listen so that you hear it, so that you know it, and so that there aren't any surprises. Okay? I just put this up on Canvas. It's not completely filled in because I've lost a couple of things, but we are going to start Unit 3A, which is Newton's first and second law. Okay? So we're going to do 2 standards yet before the end of the try. Okay? They are both conceptual standards. Mrs. Murphy and I sat down and looked at it, and I think that you guys can do them with confidence and with strength before the end of the trimester, and that's better than us just sitting twiddling our thumbs and then having to put it into extra high gear after the trimester ends. So today we're going to start with that. We're going to work through that today, tomorrow, through Friday. That's going to be our main content for the rest of this week, okay? Next Monday and Tuesday, we're going to give you one more opportunity to do some lab assessment, because I know that some of you, when you're looking at your lab statements, are going, oh man, what's going on there? And I'll be honest, I feel like 3 years from now, when we've got this really, really well-oiled machine, we'll have more lab stuff. We just haven't had a lot, and I want to make sure that you've got another chance. Does that make sense? So we're working on that right now. We're trying to formulate that so that it will be a genuine, good lab experience for you, but also one where we can hit all 4 standards, okay? So lab design, lab data collection, assessment, or, processing, and then assessment. So I think that what's going to happen is that we will make that go over 2 days. So Monday, you'll do the lab, you'll collect your data, all of that, and then Tuesday, which is one of our official finals days, will be the day that you do your data processing and your conclusion. Okay, so that's kind of the plan, and I want to make sure that you're aware of that coming up, because that's going to be next week. Okay. Next Wednesday, because we'll have a little more time in here. That's not all that we'll do these days, but next Wednesday we'll check in those 3.1 and 3.2 standards to make sure you got some sort of feedback. We're going to review next Thursday, and then depending on how many standards you decide to assess, we will do finals, probably some on the 15th, and then the 18th is our big finals day. Okay, does that make sense? So that's kind of what we're looking at. If we look at all the standards that we've done, just to give you a sense, there were 5 standards from Unit 1, there were 3 standards from Unit 2, and there'll be 2 more standards from Unit 3. So that's 10 standards total, okay? On your final, you will need to take 5 standards. You're going to have to take the Unit 3 standards because you'll need an extra chance for those. And then you can pick 3 others. If you want to do all 10, you can. I'm not going to stop you, okay? But you'll have to assess at least 5. And there will be an opportunity for a 10 in any of those. So we're going to write carefully. We're going to write assessments carefully so that there will be 10 opportunities for everything. So there's a reason for you to take a standard, whether you're, no matter where you're at. Okay, does that make sense? Okay, the tests have been kind of preliminarily graded, but I need to go back through and make sure that I agree with everything the way that things have been graded. So I will do that today and get that information back to you as soon as I can so that you can go in with full knowledge of what's going on. If you took a retake of something or you had a 7-star, I've got a pile of those papers and I will get them graded as fast as I can. It's just that I don't, there's not an infinite amount of time. Does that make sense? So I will get that stuff back to you. My goal is to have that back to you for sure by the middle, by Thursday this week, okay? Because I want you to have as much information as you can, okay? But again, just to remind you, if you go and look at those standards, it's just the top 2 scores. So there's no risk. If you got a 7 and a 9 on something, there's no risk to take it again because you'll either get a 9, which will bump you up to a 9, or you'll get a 7, and then you're just where you started. Do you know what I'm saying? So it's not like there's something out there to get you, right? I just want you to get it, and I want to help you get it, okay? questions that you have for me about kind of how things will look between now and the 18th? Yeah.
Will grades go into Power School?
I will get that. The problem is that it takes just a long time to do that. And I feel like I want to get all of those retakes done. I'm going to try and get them in. That's like, does that make sense? That is my full and complete intention. And I will let you know as soon as it happens. Is that fair? I'm sorry, you guys. It's been kind of, the Canvas thing has been harder than I had anticipated it would be, which is frustrating to me. And I'm sure frustrating to you. And we're just working through it. But if you need to know where you're at, Canvas will tell you. And if you're having a hard time understanding how to interpret it, just come in and ask me. Because I've had people come up and be like, all right, let's look at my grades. And we wrote them down, and then they know exactly where they're at. So if you need that from me, just let me know. 3 minutes, and you'll be good to go. Okay? Other questions that you have for me about logistics or about any of that stuff before we jump in and do some physics today? Okay, awesome. All right, so I just want to make sure that I didn't miss anything here. So again, the trimester 1 final schedule is up there. I had that up there yesterday so you could see it. We're going to warm up, and then we're going to start some forces today. Sound good? So get out your warm-up page if you need one, if you want a fresh start. I don't have an infinite number, but I do have some up here. You're welcome to come get one. This warm-up is maybe something you've seen before. It's entirely possible that it's a repeat. So take a look here. I'm going to give you just a couple of minutes because this is not intended to be a big thinker, just a jumping off point, okay? So I'll give you a minute or two to take a look and discuss. So, friends, I didn't ask you to get whiteboards because this is really the first little thing that we're going to do and the only big ranking task we're going to do. Does anybody have an answer they would like to share? Ooh, pick me. Did you guys come up with an answer? Corey, did you guys come up with anything? You're like kind of looking at me like, oh, maybe not. I'm not trying to put you on the spot though, so if you want me to move on, I totally can. Okay. Can you tell me where you got that from? The difference in the velocities? So what's the difference between 10 and 20? 10, right? So the change in velocity here is 10 meters per second. So that's kind of where you were getting that from. Cool. Talk to me about the change in velocity for B. What is the change in velocity for B? Negative 10? Okay. How about for C? Negative 20. Where are you getting that? I don't see any 20s up there. Where are you getting the negative 20? Abby, I kind of saw you mouthing that. Is that true?
Yeah, it goes from positive 10 to negative 10. So it's 20.
Positive 10 to 0, 0 to negative 10. That's a total of 20. Yeah, that was a little bit funny. But yeah, it is. It's negative 20. So that one's a little bit, it's kind of a little goofy because it feels like, especially because it says magnitude. When I first read this, it said, oh, the magnitude of velocity. Well, it starts off at 10 and it ends at negative 10. So let me ask this question. Is it changing speed? No, it's not. And so that's the thing you have to remember. It is changing velocity, and its change in velocity is negative 20. Yeah, which is why I'm guessing, is that where your C at the end came from? Yeah. So, but I think that's going to be negative 20. And then D, negative 10. So now that we have the change in velocity, now let's find the magnitude. So help me out, friends. Which one has the biggest magnitude of change in velocity? Magnitude just means size. C has the biggest, even though it's not changing speed. Are you with me there, friends? It's not changing speed, but it is changing velocity. It's got a big change in velocity. It's got a big change in velocity of 20 meters per second. And then what? C is greater than A. And how does A compare to B or to D? They're all the same. How are we doing? If these cars are changing velocity, what's another word we could use for that? They're changing velocity over time. What does that mean that they're doing? Is that what you said? They're accelerating. Everything that we have done up till now, friends, in this physics class, we have done a lot of physics. All of the physics that we have discussed is how something moves, right? We've discussed where it starts and where it ends, how fast it's going, if it's speeding up or slowing down. But the big question that we have not even talked about until today, welcome to today, right? We haven't asked at all what causes the change in velocity. This is the real warm-up question. This is really what I wanted to know. I want you to talk at your tables real quick and see if you can come up with a reason or an answer to that question. What causes that change in velocity? What is it that makes that happen? Just real quick. This. Did you have an idea of what causes the change in velocity? What causes these things to speed up or slow down? Yeah. A force. How many other teams came up with that answer? That word. That's a big word. It's one that we haven't yet defined until today. Welcome to today. This is your notes for today, my friends. Here it comes. We're going to write down the word. It's a big word. It's a word that makes almost all of physics happen. The word is force. My E looks a little funny. Let me fix it so it looks a little bit more legible to you. Okay? And to be clear, I'm going to ask you in just a moment to define it. And I want to be very clear that I am a big fan of Star Wars. Okay, my family already has tickets to go see the next movie on I think it's the Saturday after winter break starts. Like, we're ready to go. Okay, I want to make it clear though. Oh, it's like, are you a Star Wars fan, Mara? Not yet. Okay, we need to work on this. Okay, it's important. Like the cultural experiences. But so the thing that I want to make clear for now though is that we're gonna leave all of our Star Wars love or lack of knowledge, okay, aside. I want you to define force in a true, real life, not made up sci-fi fantasy way, okay? So I'm going to give you just a minute to write down, this is going to be by yourself, no talking yet, as much as you know about the word force, okay? That can be a lot of things. I want you to be thoughtful, I want you to be creative, I want you to think outside the box, write down what you know, again, not Star Wars related, okay? Real physics related. What do you know about the word force? I'm going to give you a minute to think by yourself, and then I'll let you talk to your tables, okay? Go. So it's quiet thinking time right now. Write down everything that you know, or things that you think of when you hear the word force. That is your minute of sharing. Now, here's the game. So again, I call this the brain dump, right? I just want to know everything that you've said, right, wrong, or indifferent, and I want to make it really clear, right? We're just kind of starting this out. So we're not going to judge each other. We're going to be supportive and helpful. The deal is, though, that you have to listen so that you don't repeat something somebody else has already said. Okay, that is the key. All right, so here, I've got the word force up here. We're going to start. We're just going to go around table by table. I think, Kaylin, we're going to start with you. Is that okay? And it doesn't have to be at your table. We're going to start at that table. Tell me something you wrote down about a force. Go. There are push and pull forces. Okay? So the game is here, friends, that if you didn't have this written down, you're going to add it to your list, right? And if you did, then maybe put a little check mark by it so that when it comes to you, you're not like, oh, push and pull, because we already have that written down. All right. We're going to go backwards. So, my friends there, what you got?
Change the velocity.
changes the velocity. It does. A force changes velocity. All right. Olivia, do you guys have something in the back? Say that one more time. Okay, so it can make something have velocity. So you kind of mean like that if something is at rest and a force acts on it, then it would then have some non-zero velocity? Awesome. That's great. Thank you. All right. Damani, your table. What you guys got?
We have. Okay, we had that it causes a change in motion.
Causes a change in motion.
Like causes
What do you mean change in motion?
like I don't know.
I don't think it's wrong. I think it's great. But I'm just curious as to what you meant by that, because it's kind of like it's kind of a big statement.
Like you can just like it doesn't have motion and then you put like force through it now it's moving. Like it's like push the ball.
Okay. Sweet. All right. You guys got more?
Non-natural forces require energy.
Whoa, say that one more time. That was lots of stuff.
Non-natural forces require energy.
Non-natural forces. Okay, now, friends, shh. I hear some tables going, oh my gosh, what are we going to do? Hold on, just wait, just be patient. But before we do that, I got to ask you, what do you mean non-natural?
So like a natural force was.
Oh, I'm sorry. Physicists, we're working together. So I don't want you to freak out about what you're going to say. Don't worry about that. I want you to listen, right? We're working as a team. And Abby's got the floor. Say it again.
A natural force would be like gravity that you can't necessarily start or stop.
Okay.
And then a non-natural force would be like the movement of a car, which requires fossil fuel or like Tesla.
Electricity.
Yeah.
Yeah. Okay. Okay. So I just wanted to. So natural, like you're kind of saying, like things that you can turn on and off is a non-natural force. Is that true? Okay. Cool. So I was about to write non-natural again. So it can be changed, maybe, or turned off. Okay. And requires energy. What do you mean by energy? So do you mean like fossil fuels or whatever in that way? Okay, cool. I just want to make sure I was understanding. Thank you so much.
Welcome.
Awesome. All right. Require energy. So some sort of like fuel or something. Okay. Okay. I've got 1, 2, 3, 4 groups, and then we're going to come around again. I'm going to give you 30 seconds right now because I feel like some people are like, oh my gosh. Oh, they good. But I'm gonna pause for just a moment because I want everybody to add some more. Think about types of forces, because we just started talking about this non-natural force, and she mentioned one in there. If you were listening, you may have heard it. If you don't have any other things written down, go ahead and have a conversation to everybody. What kinds of forces exist out there? Maybe that's something you can add to your list. Go, go, go. I'm going to give you 30 seconds. Go, go, go. Don't make me. I didn't hear what you said. Got stuff? All right, 30 seconds is up. So, and you don't have to tell me a type of force, but it might be something else. All right, Andre, what you got? Friction. If you don't have that one written down, write it down. Oh no, did they just take yours?
No.
They just like swiped your idea. Oh man, do you have other things to tell me? What else you got?
I said it can be used to create different types of energy, like kinetic energy.
Okay.
I'm very ignorant in that,
Okay. So So that's a little different than this, though. So you're saying, so non-natural forces require energy, but you're saying that you can also use a force to make energy? Is that what you're saying?
Yeah.
Okay. All right. All right, and did you guys come up with other types of forces or something else to add?
You said like positive and negative of magnets.
Ooh, yeah. So that's awesome. Okay, so I need to just get my little green pen here. So like you got like magnets, magnetic energy, or not energy, forces, magnetic forces, sorry. Yeah, the positive and negative, I'm just gonna pull this out a little bit. Positive and negative isn't actually magnets, it's what? Positive and negative, you talk about this in chemistry a bunch. It's not like the poles of the magnet, but it's like proton or an electron. What are they? They're positive and negative charges, electric force. Yeah. 2 for 1 right there. Nice. All right, my friends, what you got?
I think you said that the weight of an object is like the force of gravity on an object.
Excellent. All right, coming back to my friends over here. Other things you want to add? Did you have more stuff? No? Back tables, more stuff to add? Other ideas? No? It's okay. Yeah, go ahead.
Okay, am I right in saying like so like, you have a spring-
Okay, hold on. Friends, again, we are working together. Whether it's me talking or one of your classmates talking, trying to speak to the entire class, you need to show respect. You need to show kindness. Go.
So like, let's say that you have a spring and you use your force to bring it down,
Mm-hmm.
and that creates potential energy.
That does.
And then you let go of it, then it creates kinetic energy.
Yeah. Yeah. So you're using a force. It's not really to make energy, though.
Yeah.
It's to transfer. Can I say transfer?
Yeah. Oh, yeah.
Yeah. But we can also add springs or elastic to the list of forces, too. Yeah. Your paper should be getting full. Yeah? Other things? Do you guys have more stuff even? It's okay if you didn't. I just want to make sure that I've gotten everybody out there. You guys have more? No? Max? More stuff? No? All right. Everybody's brains have been dumped on the paper? All right, cool. So everything that you've said here is awesome. Everything that you've said here is correct. There are a lot of pieces to this that are really, really important, and I want to kind of put those pieces together. The first thing that I want to put a big box around, so you might want to get your colored pencils out or your glitter pens or your highlighters or just a pencil and circle, okay? The first thing that I want to push, that I want to highlight is this one here, okay? A force is absolutely, it seems very simple, but a force is a push or a pull. Anytime that something's pushing or pulling, there is a force acting on it, okay? So that is the force, I should say, okay? A force absolutely causes a change in velocity, or can, I should say, okay? It can cause a change in velocity. That's number 2. These ones down here are really saying the same thing as the blue one. Would you agree? Yeah. Making something have velocity, changing motion, those are really just kind of saying the same thing. They're not wrong, but they're just, I kind of feel like they all kind of fit together, okay? The other thing that isn't really up here, but I want to make sure is expressed, is something that is really, really fundamental to the understanding of forces, okay? And the fact that I want you to understand is that a force is an interaction, okay? And it's an interaction between a very specific number of objects. So if you have something pushing or pulling on something, how many objects are involved? Say loud. 2, she says really loudly and with lots of confidence. Yes. Okay. 2. It's always got to be 2. Okay. That's the other piece that's super important that I want to make sure you have written down. Okay. Is that a force is an interaction It is always 2 objects. It is never 3 objects, and it is never 1 object. A force is an interaction between two objects. Okay? So on your notes, you should have these three things highlighted or circled or put lots of stars by or whatever it is that makes it so that you see that so that you know. Okay? So that's what a force is. Unit 3 is all about studying how forces affect objects. And in order to figure out how an object is affected by forces, we like to draw pictures. Okay? So if you are an artistically minded person, if you are a visual person, this is going to be a great opportunity for you. If, like me, you're not very artistically minded, it's totally fine because your pictures don't have to be pretty. Okay? They're just for you and they're just for you to understand. Regardless, we're going to draw some pictures. I'm going to tell you all about these very fancy kind of pictures. So we're going to put a big line here in your notes, okay? And then we're going to write down this very specific way to draw pictures of forces on objects, okay? They have a very kind of funny name. The name for this kind of picture is a free body diagram. And a lot of times, because I am lazy, instead of writing free body diagram out on a test or on notes when I'm writing something or whatever, instead of calling it a free body diagram, I'm just going to take the first letter from each of those words and I'm going to call it an FBD. Okay? So if you see that acronym FBD, it means free body diagram. So far, so good? Fantastic. So then you're saying, okay, what's a free body diagram, Ms. Carmeling? And I'm going to tell you, here it comes. Here is the definition. It's very simple and very specific, okay? A free body diagram has one object, okay? One object. And all of the forces acting on that object. What's a force? It's a push or a pull, right? It's going to be pushing or being pushed or pulled on by something. So it's kind of a big statement. But the keys here is that it's how many objects? One. And all the forces acting. Okay? Seem easy enough? We can handle it? All right. So I want you to watch carefully. We're going to draw a free body diagram. You ready? Okay, so this one's going to be something you've seen before. You've met my frog before. You're going to see a lot of my frog this unit. So here he is. Hello, hello, hello. Okay, so I'm going to let him go. Remember, we're assuming that there's no air, except that there's got to be air so you can hear me and all of that good stuff, and so we can breathe these good things, right? But in terms of the motion of the frog, no air. Okay, so I want you to watch. And when I say now, that's what I want you to think about what forces are acting on the frog. You ready? Here he goes. 1, 2, 3, now. Okay, got it? Not a big surprise to you, I hope. We're going to go ahead and draw this example. So here we go. I'm going to call it example 1. We're going to do a few of them. Here we go. Example 1. I'm going to call it frog falling. And I'm going to draw an object. Which object am I worried about here? The frog. So I'm going to go ahead and draw my frog. You go ahead and draw your frog. I'm going to draw my frog like this because that's about my artistic level. Okay? And you can draw your frog as much as you want. Now, sometimes my artistic friends decide to take 20 minutes to draw this very, whatever. Like the thing that I want you to do is not get so distracted doing that you miss all the physics. You with me? Okay. So do that later on your own time. Draw your frog like this. Maybe it's pretty cute. All right. So there's my frog. That is my one object. And now I need to draw or write down all of the forces acting on that object. I heard a lot of you yell out what that force was. What did you call it? Gravity. Now, I would agree that gravity is acting on my frog. But we need to be a little clever. Are you ready? Because we said that a force is an interaction between how many objects? 2 objects. And they both have to be physical things. Is gravity a physical thing? No, it's not. It's not like a yeah, I can't hold it. So, quick question for you. Is the frog feeling a force that we call gravity? What is pulling or pushing on the frog that causes this gravitational force? The mass of the earth. The earth is the other object. That's exactly right. You guys with us there? Yeah. So when we label our forces, I'm going to put a little note here. When we label our forces, the forces are going to be labeled with the two objects. Oops, got ahead of myself there. Interacting. So there's one force acting on my frog. It's pulling which way? Which way is it pulling on the frog? It's pulling down, isn't it? It's pulling down. So I'm going to draw an arrow, also known as it starts with a V, vector, right? It's got magnitude and direction, and we'll talk about that in a second. And it's the force of the earth on the frog. How are we doing? We okay? So we're going to write that as the force of the earth on the frog. And here's a little hint for you. Remember that it's a free body diagram is one object and all of the forces acting on that object. So each of the forces, when I'm drawing a free body diagram of a frog, is going to be the force of blank on the frog, in this case, or on the object, whatever that is. So this is the force of the earth on the frog. Okay. So far, so good? All right. I'm also going to put FG in parentheses there, just so that I remember that it's a gravitational force. Okay. We're going to come back in a minute and or maybe tomorrow, depending on how long things take, and define this force. But before we do that, I want to do example number 2. So I'm going to go ahead and draw example number 2 right under example number 1. Example number 2. Okay. Is a frog sitting. You ready for this one? There he is. I might have to wiggle around so you can see him, but he's sitting right here. Can you see him? Everybody got him? It's pretty exciting, right? Like, look at him. He's so well trained. I know, right? Okay. Take a look. And then I want you to draw or start to draw a free body diagram of the frog sitting. So the question goes, what forces are pulling or pushing on the frog? What interactions is the frog having with objects? Okay? So you're going to draw your little frog. He got whiter today, I guess. Oops. It's not kind of a consistent size. Are there any forces acting on my little frog? Yeah, what's one of the forces acting on my frog? Gravity. But it's not just gravity. What object is pulling or pushing on my frog that causes that gravitational force? The earth, right? It's the earth. The earth is pulling down. So here we go, friends. The earth is pulling down. The force of the earth on the frog, FG. And I want you to write it just like this every single time. Okay? Write it just like this every single time. So there's the force of the earth on the frog. Is there anything else acting on my frog? Yeah. The table. Which way do you think the table is pulling or pushing? I think it's pushing up. I think that seems reasonable. Let's go ahead and draw that force. The force of the table on the frog. How did you know that it was pushing up? It's being held up. So I'm gonna keep asking questions. Is that okay? How does the size of this force, the force of the table pushing up, compare to the force of the earth pulling down? What do you think? Does that kind of make sense that they need to be equal? It kind of makes sense that the force of the table on the frog, which pushes up, so I'm going to make that a positive one, plus the force of the earth on the frog, which is going which way? Down. Those two things need to add up to 0. And the reason for that's really important. What is it not doing? Not just that it's not moving, but there's a really important little piece to that. It's not that it's not moving, but it's not that it is not. It starts with an A. It's not accelerating. Are you with me there? It's not accelerating, and because it's not accelerating, means that the total force equals 0. That's a big deal. That is a big deal. Okay? All right. We've got just a couple of minutes. Awesome. We're going to keep cruising for just a sec. I want to start defining that gravitational force a little bit today. Is that okay? What do you guys know about gravity? Theo, you said when I asked you what the object was, you said it was the mass of the earth, right? So the mass of the earth is the thing that's causing this gravitational force. You know that gravity exists on earth. Does gravity exist on the moon? It does, but not as much. Why not? What is it about the moon that makes it so that there is less of a gravitational pull on the moon? It's smaller. It has less mass. Question for you. This is an important one. The earth is pulling on the frog. Question. Am I pulling on the frog?
Wait, repeat that.
The question was, am I pulling on the frog? It's sitting here, like right now. This very moment. Is Theo pulling on the frog? Is Mara pulling on the frog?
Yeah.
Why?
Wait, is it because you have mass when you're on Earth?
Yeah. Okay, so let's write this down. Hold on. The bell's going to ring in just a second. We've got to write this down. Say it one more time. Yes. The force of gravity is a force between any two objects with mass. Okay, so I want you to watch really carefully. You ready? Watch it again. I'm going to stand this way so you can see it. Which way does the frog fall? Why doesn't he fall towards me?
Because it has more.
Why?
Because there's more mass on the Earth.
You got it. I'll see you guys tomorrow.
So
Have an awesome day. Whoa, I'm throwing stuff. Did somebody say my name?